Next lesson is about another measure of variability. It's about box and whisker plots. A box and whisker plot summarizes a set of data along a number line. Box and whisker plots are different from those line plots that we saw yesterday because it divides a set of data into 4 equal parts that are going to be called quartiles. Think quarters, quartiles. So I'm going to give you a second, go through and read this box, pause the video, read them, and then we're going to make 2 examples here. So in our first example, our data is already in order for us. So our job is to find the median. So beginning, end, beginning, end, beginning, end. Here's my median right here, 80. So 80 is that. I now exclude the 80. So I look at this bottom set. This right here is the median of the bottom. And this right here is the median of the top. So far we have the median. This is the lower quartile, this is the upper quartile, and then I have my extremes, which go on the end. So we put dots for these right above. The 65 repeats, so we're going to actually just put 1 dot. We have a dot above the 80, dot above the 90, and a dot above the 95. For the 3 middle values, we create the box. Now remember, this one overlapped as a middle value, so we're going to turn it into the box. And then we extend the whiskers off to the end. So if this one doesn't go anywhere, it won't have a whisker down to the left-hand side. So that's your first one. If we don't have a median, so we're going beginning, and the median would fall right here in the middle. Since both those values are 80, we know the median would actually be 80. Because I didn't use either of these, they now become part of the sets. So now my median falls between 65 and 70, which would be 67.5. My median is going to fall between 85 and 90, which would be 87.5. My lower extreme is 65, and my upper extreme is 95. So plot a dot. 65, 67.5, 80, 87.5, and 95. The 3 middle ones make your box, and then extend your whiskers off to the sides. So there's your example of your box and whisker plot. In terms of looking at box and whisker plots, a shorter box and whisker plot means that the data is bunched together and has less variability, so the data are more similar, they're a little bit better. A longer box means that the data is spread out and has more variability. So one of the other things that we can find is what's called the interquartile range, and it basically means it's the range of the box. So if I were looking back at this example, my range of the box would be 90 minus 65, which is going to be a range of 25. In here, I would have had 87.5 minus 67.5, which is a range of 20. So taking a look at this next one, this is a triple box and whisker plot. It allows us to kind of compare things for 3 different cities. So what's the median temperature for Seattle? Seattle, median would be in the middle, it's 59 degrees. Which city tends to have higher overall temperatures based on the plot? Since we're on a number line, we're really just looking for which plot is further to the right. That would definitely be San Antonio. Which city has the smallest interquartile range? So we're looking for in this one, which one has the smallest box? So really, I can go through and actually calculate them if I'd like. I'm thinking it's Seattle. So I'm going to look 69.5 minus 51.5. It's a difference of 18. If I look at this one, I can tell it's going to be over 20. So Seattle has the smallest interquartile range. Next question is which city has the largest interquartile range, so the largest box? Definitely New York. Which city has less variability in its average temperatures and why? So less variability would mean that the box is actually smaller. So, or the whole graph is actually smaller, my apologies. That would actually be Seattle. And that basically tells us that the temperatures must be fairly consistent. if you think about that, compared to San Antonio is relatively consistent too, it looks like, as well. Pretty close, and you can think this is this is in Texas versus New York. So think about New York City. You have winters where it's really cold, but then you have summers where it's really warm too. Last question down here. Since a box and whisker plots divides the data into 4 equal parts, each quartile on the plot represents 25% of the set of data. So down here, which statements must be valid? Fitness Plus has a smaller spread in the upper 25% of the hourly wages than the Fitness Center. So this, if we're looking, this is 21, 22, 23. So this is a spread of 1 in the upper 25%, and that's a spread of 1 in the upper 25%. So that's not true because they're the same. Fitness Plus has a smaller spread in the middle 50%. So we're going from 14 to 20. That's a spread of 6. And that says middle 50%. So that's the middle 2 pieces. This goes from 15 up to 22. So it's a spread of 7. So Fitness Plus has a smaller spread than the Fitness Center. I would agree. Fitness Center has more employees earning an hourly wage of $17 than Fitness Plus. So $17 happens here. So this group has 50% of its employees earning that. And this has 2 sections plus more. So this is 50% plus, more than 50%. So the Fitness Center has more employees earning that. That is true. And the Fitness Center has a larger range in employee hourly wages than Fitness Plus. So we go from 23 down to 13. Which is range of 10, and this goes from 11 up to 21, so 21 minus 11 is a range of 10. So that's not true because the ranges are actually the same.